Hello and welcome to the Introduction to Complex Numbers. Now the good news is that complex in the mathematical sense doesn't really mean complex the way we understand complex. It's not necessarily more difficult or more tricky or more hard. What complex numbers are, it's a combination of real numbers and imaginary numbers. And we'll talk about that. So as we've talked about sets of numbers, there are always new numbers that evolve. Negative numbers, rational numbers, irrational numbers. At some point, those were all new to people. And the same way here with a problem like this. If we're solving x squared plus 1 equals 0, then to try to get x by itself, we have to subtract 1 and get x squared equals negative 1. And then we just think, oh, just take the square root, and there we have it. Now we've got x equals square root of negative 1. The problem is, there is no number that times itself equals negative 1. There is no number that we know that's real, that could be on the number line, that times itself equals negative 1. Any negative times itself will be positive. Any positive times itself will be positive. It's impossible to have a number times itself to equal negative 1. So this was a problem that mathematicians found. But at the same time, this has to happen, this has to work, because this has a solution, and it exists. There was an Italian mathematician named Bombelli who was working through this problem and said, okay, well, there is no number that times itself equals negative 1. But let's imagine that there is a number that times itself equals negative 1. And I'm just going to call this thing I. And we will say that I is going to be the thing that times itself equals negative 1. Now, it's not a variable, it's a number, but it's not a real number. We'll call it an imaginary number. The thing that times itself equals negative 1. So if I have this thing that times itself equals negative 1, then what if I were to square it? Then I would have the thing times itself equal to, negative 1. And this I can use then. These are the two things that we want to talk about, and we want to use as imaginary numbers. And from here, we can extend our thinking a little bit and say, okay, well, then what would be if I is the square root of negative 1 and I squared is then the number negative 1, what would be I to the third? Well, I to the third would have to equal I squared times another I. And I squared we know is negative 1. So that's just negative 1 times another I. And negative 1 times I is negative I. So this is just negative I. I to the fourth? Well, I to the fourth would be I to the third times another I. And negative I times positive I would be negative I squared. And I squared is special. Every time we see I squared, we should think, that is negative 1. So this is negative 1, which is 1. I to the fifth, that's taking this I to the fourth times one more I. So that would be I to the fourth times I. We know I to the fourth is 1. And 1 times I. Okay, I to the sixth would be I to the fifth times another I, every time multiplying by one more I. I times I is I squared, and I squared is negative 1. Here we go again. The I to the seventh would be this times another I, which is negative I. I to the eighth, I'd be multiplying it by one more, which is negative I squared. I squared is special. We know that's negative 1, so this is 1. And you see the pattern here. I, negative 1, negative I, 1. If I keep going, 1 times I is I. I times I would be I squared, which is negative 1. Negative 1 times another I is negative I. And negative I times negative I times another I is negative I squared, which is negative 1, which is 1. And so you see this pattern. Every 4, it repeats. So what is I to the 16th? Well, this would be 13, 14, 15, 16 would be the same as 12, and same as 8, and same as 4. It would be 1. I to the 20th, 1. You can always divide by 4. If I said, what is I to the 25th? Well, if I divide by 4, that is I to the 24th with one more I. I to the 24th is 1. And 1 plus one more I is I. We could find I to the 100th is 1. I to the 200th is 1. We could find all of those things by thinking about cycles of 4. Now, the way that imaginary numbers really helps us is when we're dealing with electricity problems, which is going to be a little bit more complicated than the scope of this course. But in electricity problems, there are things that are negative square roots. And so I just gives us a way to be able to handle negative square roots, like the square root of negative 16. We know there is no number that times itself equals negative 16. But we can deal with this with imaginary numbers by saying that this is the same as square root of negative 1 times square root of positive 16. And we do know the square root of positive 16. That's 4. And the square root of negative 1, that's I. We usually would write it with the number first. So we would write this is equal to 4I. That's the square root of negative 16. Sometimes it won't simplify like this. Square root of negative 5, we know that's equal to negative 1 times 5. This is I, and this doesn't simplify at all, so that's just I square roots of 5. Something like negative 28, again, we can simplify and say that's negative 1 times positive 28, and positive 28 we can do. We know this is 7 and 4, 2 and 2, there's a plane 2, there's a radical 7, and then this is I, and we put the I with the plane, so 2I radical 7. Pause the video now and try example 4. And start the video. Hopefully you did it like this. Negative 1, 72. This we can do. 9 and 8, 3, 3, 4, 2, 2, 2. Pair of squares, pair of squares. So I have plane 3, plane 2, radical 2 over here. And this is I. So I'll have 6I radical 2. Did you get it right? Now here's where it gets a little bit interesting. We can multiply these together. We can do this. This is I radical 10. Actually, let's back it up a second. We can make this square root of negative 1 times square root of 10. We can make this square root of negative 1 times square root of 2. This is I. This we can't break down anymore, but we can multiply these things together. Here's I radical 10 times I radical 2. Now, I times I is I squared. That's important. We know that. Square root of 10 times square root of 2 is square root of 20. This is negative 1. That's what I squared is, remember? And then we can break this down. 5 and 4, 2 and 2. There's a plane 2. And we have a leftover radical 5. So this becomes negative 2 square roots of 5. And the last one here, this one is not negative, it's positive. We can deal with this. 6 and 4, 2 and 2, 2 and 3, radical, radical pair. So this is 2 radical 6. And this one, we need to split up the negative with the positive. This is I, and this is 2. So this is just 2I. This is a real number, even though it's irrational, it's real, 2 radical 6. And this is imaginary. really sloppy, sorry. We always put the real part before the imaginary. So we'd write 2 radical 6 plus 2i. When we're adding and subtracting, the real part would come first, the imaginary part would come second, so it looks like a plus bi. When we're multiplying, the imaginary always comes in the front with the other planes. 2i radical 7, 6i radical 2. So this is our introduction to complex numbers. It's really not super hard. It's not super complex. As long as you understand that I is the thing that when squared equals -1. Have a great day.